Hi, this is Javin Kharor, a chemical engineer by profession, going to continue our today's topic, vacuum pump. What is that? A vacuum pump is a device that draws gas molecule from sealed volume in order to leave behind partial vacuum. The job of the vacuum pump is generate a relative vacuum within a capacity. Now it's time. Pump can broadly categorize according to three techniques. Positive displacement pump. They are mechanical and mechanism to repeatedly expand a cavity, allow gases to flow in from chamber, seal off the cavity, exist in the atmosphere. Momentum transfer pump, also called molecule pump, use high-speed jet, dense fluid, or high-speed rotating blade to knock gas molecule out of the chamber, and trap pump capture gases in solid or adsorbed state. Positive displacement pump are the most effective for low vacuum momentum transfer pump in conjunction with one or two positive displacement pump are the most common configuration used to achieve high vacuum. In this configuration, the positive displacement pump serves two purposes. First, it obtains a rough vacuum in vessel being evacuated before momentum transfer pump can be used to obtain high vacuum, as momentum transfer pump cannot start pumping atmospheric pressure. Second, the positive displacement pump backup the momentum transfer pump evacuating lower vacuum. The accumulation of displaced molecule in the high vacuum pump and trap pump can be added to rough ultra high vacuum. They require periodic regeneration surface that trap air molecules or ion. Due to the requirement, the available operation time can unacceptability salt in low and high vacuum, thus limiting their uses. The ultra high vacuum pump also differ the detail like manufacture tolerance, sealing material, pressure flow, admission or no admission of oil vapor service interval, reliability, tolerance to dust, tolerance to chemical, tolerance to liquid and vibrations. Okay, move further. A positive displacement pump, a partial vacuum may be generated, increases volume of container to continue evacuating chamber identified without require infinite growth. A compartment of vacuum can be repeatedly close off, exit and expand again. This is principle behind positive displacement pump. For example, the manual water pump inside the pump, the mechanism expand a small sealed cavity to reduce its pressure below that atmosphere. Because of the pressure differential, some of fluid from the chamber is pushed into pump small cavity. The pump cavity is the sealed end from the chamber, open the atmosphere and squeeze back to minute size. More sophisticated system, they are used the most industrial application, but the basic principle, cyclic volume removal is the same. They are the rotary vane pump, the most common, the diaphragm pump, zero oil contamination, liquid ring, high resistance to dust, piston pump, fluctuating vacuum, scroll pump, high speed dry pump, screw pump, vehicle pump, external vane pump, root blower, also called booster pump, has highest pumping speed but lower compression ratio. Multi-stage root pump that combine several stages providing high pumping speed with better compression ratio. Tolerant pump and low pump. The best the pressure of rubber and plastic seal piston pump system typical of 15 kilopascal, while scroll pump might 10 pascal. Rotary vane oil pump clean and empty metallic chamber can easily achieve 0.1 pressure. The positive displacement vacuum pump move the same volume of gas with each cycle, so its pumping speed is constant unless overcome by back shrinkage. Now, second, momentum transfer pump. The momentum transfer pump gas molecule, they are accelerate from the vacuum side, exit side, which is usually maintained reduced pressure by a positive displacement pump. Momentum transfer pumping is only possible below pressure above 0.1 kilopascal meter flow the different pressure based on low fluid dynamic at atmospheric pressure and mild vacuum. Molecules interact with each other and push on other neighboring molecules is what is known the viscous flow. When the distance between molecules increases, the molecule interact with wall chamber more often with other molecules and molecule pumping become more effective than the positive displacement pumping. The regain, the generally called higher vacuum, the molecule pump screw out of larger area when the mechanical pump and do so more frequently making them capable much higher pumping speed. They do this is the expanses the seal between the vacuum and their exit. Since there is no seal, a small pressure exit can easily cause backstreaming through the pump. This is called stall. A high vacuum, however, pressure gradient have little effect. Fluid flow molecule pump can attain their full potential. The two main type molecule pump are diffusion pump and the turbo molecular pump. Both type pump blow out gas molecule that diffuse into pump by imparting momentum to gas molecule. Diffusion pump blow out gas molecule, jet of oil or mercury vapor, while turbomolecular pump are higher speed fan pushes the gas. Both the pump will stall and fail to pump if exert directly atmospheric pressure. So they must exert lower grade vacuum created mechanical pump. In this case, called a backing pump. As with high displacement pump, in best pressure will be reached when leakage, outgassing, backstreaming equal the pump speed, but now minimize leakage and outgassing to level comparable backstreaming become much more difficult. Now, regenerative pump. A regenerative pump utilizes vortex behavior of fluid. The construction is based on hybrid concept centrifugal pump and turbo pump. Usually it consists several set perpendicular teeth on rotor circulating air molecule inside stationary hollow groove like multi-stage centrifugal pump. They can reach the 1 into 10 raised to minus 5 m bar and 0.001 pascal when combining with whole back pump and directly exert the atmospheric pressure. This type pump suffers from higher power consumption compared to turbomolecular pump. The lower pressure since most power consumed to back atmospheric pressure, this can reduce nearly 10 times by backing with small. Now, entrapment pump. Entrapment pump may be cryopump which uses cold temperature to condense gases to a solid or adsorbed state. A chemical pump which react with gases to produce solid residue, or ion pump which uses strong electrical field, ionized gases propel ion into solid substrate. Cryo model and they are cryopumping. Other type of sorption pump, non-evaporative getter pump, the titanium sublimation pump. This type evaporative getter that can be used repeatedly. Other type, Venturi vacuum pump and steam ejector. Now is performance measure. The pumping speed refers volume flow rate of the pump as its inlet, often measure the volume per unit of time. Momentum transfer and entrap pump are more effective some of gases than other, so the pumping rate can be different for each of the gas being pumped and the average volume flow rate. The pump will vary depending on chemical composition of gases remaining in the chamber. Throughout refer the pumping speed multiplied gas pressure inlet and is measured unit pressure volume per unit time as constant temperature throughout proportional number of molecules being pumped per unit time. And therefore mass flow rate of the pump when discussed leak in the system backstreaming through the pump throughout refer volume leak rate multiply pressure at the vacuum side of the leak. So the leak throughput can be compared to pump throughput. Positive displacement and momentum transfer pump have constant volume, flow rate, pumping speed, but as chamber pressure drop, this volume contain less and less mass. So all through pumping speed remain constant, the throughput, mass flow rate drop exponentially. Meanwhile, leakage, evaporation, sublimation, and backstreaming rate continue produce constant throughput onto the system. Now step vacuum pumps are combined with chamber and operational procedure into wide variety vacuum system. Sometimes more than one pump will be used in series or parallel in single application. Partial vacuum or rough vacuum can be created using positive displacement pump that transport gas load from inlet port and outlet port because of their mechanical limitation, such as pump can only achieve a low vacuum. To achieve higher vacuum, other technique must be used, typical in series, usually flowing an initial fast pump down with positive displacement pump. Some of example might use oil shielded rotary vane pump, the most common positive displacement pump, baking diffusion pump, or dry scroll pump, baking turbo molecule pump. There are other combinations depending on level vacuum being sought. Achieve high vacuum is difficult because all the material exposed to the vacuum must carefully evacuated for their outgassing and vapor pressure property. For example, oil, grease, rubber, plastic, gasket use seal for vacuum chamber. Most, not boil, of exposed vacuum or the gases they produce would prevent creation of the desired degree vacuum. Often all surface exposed vacuum must be baked higher temperature. The dry bulb absorbs gases.